Hi, this is Giridhar from eMath. As eMath, this video series is an initiative of a free chapter-wise revision for all SSLC students of Karnataka. In this video, let's revise the chapter Polynomials. Let's get started, right? Chapter 9 Polynomials. So firstly, we'll have to define what is the defined degree of a polynomial, right? So it says if p of x is a polynomial in the variable x, then the highest power of x in p of x is called the degree of the polynomial p of x. What do we mean by this? If p of x is any polynomial in the variable x, then the highest power of x in that particular polynomial will be called as the degree of a polynomial. For example, if we take 4x plus 2, then the degree of this particular polynomial is equal to 1, right? So 4x plus 2 is a polynomial of the variable x in degree 1 because x is the only variable we have and the power of that variable is equal to 1. So its degree is also equal to 1. Similarly, take the other polynomial x square plus 5x minus 2. So this is also a polynomial of degree 2 because x square is the highest power of x here, right? 2 is the highest power. That's the reason degree is equal to 2. Then define all the types of polynomials with an example each. So there are 4 types of polynomials, namely the first one among them is about linear polynomial. So what is this polynomial all about? A polynomial of degree 1 will be called as a linear polynomial. For example, 2x minus 3 is one of the example, and this root 5x plus 7, etc. This is one of the example. Then the second type of polynomial is about quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. For example, 2x square minus 2x plus 5, then 4 by 3u plus u square, etc. These are some of the examples of a quadratic polynomial. And then the third one, cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. For example, x cube minus 3x square plus 5x plus 7. This is one of the example of a cubic polynomial because the highest power of x is over 3 here. That's the reason it's an example for cubic polynomial. Similarly, say the last one we have, it's the biquadratic polynomial. The polynomial of degree 4 is called the biquadratic polynomial. For example, x power 4 minus 2x cube plus 5x square minus 4x plus 5. In this polynomial, we see that there is the highest power of 4 in this polynomial, right? So that's the reason it's an example for a biquadratic polynomial. Then we also have something called zero of a polynomial in this chapter, right? So what is the zero of a polynomial? If p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in the polynomial p of x, and that is called as the zero of a polynomial. So what are they saying? If given any p of x is a polynomial in the variable x and if k is any real number, okay, then the value which is substituted or the value obtained whenever x is going to be replaced by k in the polynomial p of x, and whatever that value we obtain, that is called as the zero of a polynomial, right? Let's look at the illustrations now. Yeah, illustration 1. It says the sum and product of the zeros of a quadratic polynomial p of x is equal to ax square plus bx plus c or minus 3 and 2 respectively. Then show that b plus c equal to 5a, right? So what have they given is they have given the sum and product of this quadratic polynomial or minus 3 and 2 respectively. Then we need to show or we need to prove that b plus c equal to 5a. Okay, let's see how we do it. So since they have given the sum and product values as minus 3 and 2 here, right? Given that alpha plus beta, by keeping alpha and beta are the two zeros of the quadratic polynomial, we will take sum of the zeros first, that is alpha plus beta equal to minus 3, and the formula is given by minus b by a, right? The sum of the zeros is minus b by a, and that is equal to minus 3. Minus minus will get cancelled out and the value of b will be equal to just 3a. Let me call it as equation number 1. The same way, next step, which is about alpha beta, that is the product of the zeros, will be equal to 2. They have given the question, right? So the formula is about C by A. Alpha beta is equal to C by A. So C by A is equal to 2. Then C will be equal to 2A, which is our equation number 2. Now what we need to do is adding both the equations 1 and 2, we get, okay, we get what we get, B plus C. B plus C will be equal to 3A plus 2A, that is B plus C is equal to 3A plus 2A is 5A. So which proves the result, right? So this is how we can prove it. Now let's go to the last section 2. It says find the quotient and remainder. Find the quotient and remainder when p of x is equal to 3x cube plus x square plus 2x plus 5 and g of x is equal to x square plus 2x plus 1, both are divided. So we'll have to divide like this. Since the first term is here is x square and here we have 3x cube, the what should be multiplied to x square to get 3x cube? It's 3x. 3x should be multiplied to x square to get 3x cube. So x square into 3x will be equal to what? 3x cube. Then 2x into 3x will be equal to 6x square. And then again plus 1 into 3x will be just 3x. Then changing the signs, minus, minus, minus. And then first term is always the same terms with opposite signs. So we can cancel these two terms. And then finally we get, yeah, minus 6 and plus 1 will be equal to minus 5x square, and here minus 3 and plus 2x will be minus 1x, and then plus 5 we bring down here, okay. And then what should think of an expression what should be multiplied to x square to get minus 5x square? It's minus 5, right? So take write minus 5 here and multiply all the terms of this and write here, right? So minus 5 into x square will be equal to minus 5x square. Then plus 2x into minus 5 will be minus 10x, and this is our plus 1 into minus 5 will be minus 5. And after changing the signs, the first term obviously it will get cancelled each other. And then look at the next term, that is plus 10 and minus 1. 10 minus 1 will be equal to what? 9x, and this is 5 plus 5, 10. So 9x plus 5 is what remains, right? So our quotient q of x is this one. This is our answer. So quotient is 3x minus 5, and our remainder is r of x is 9x plus 10. So this is how we can find the quotient and remainder by dividing one polynomial by another polynomial. Thank you. We will get back to you with the revision of next chapters.